When you're swiping through your Samsung phone, using your apps, changing your settings, you're really just interacting with the surface. That polished Android interface is just the beginning. Because underneath it all, there are these powerful, hidden engineering layers. They're built for diagnostics, for service, for deep-level control. And today, we're going to peel back those layers and see what's really going on under the hood.
So, have you ever really wondered what's going on down there? I mean, way beyond the normal apps and settings menu, there is a whole world of service menus and special modes that give technicians and, the really savvy users, direct access to the hardware. Now, let's be clear, this is not your everyday settings screen. This is the stuff that can bring a phone back from the dead. Or, if you're not careful, send it there for good.
Okay, so the first secret layer that most people stumble upon is something called USSD codes. You just punch these secret codes into your phone's dialer, and bam, a hidden menu pops up. They aren't apps, they are direct commands that talk to the phone's hardware and the network. For example, on an older classic like the Galaxy S5, you could type in a code like *#9900# and force the phone to dump all of its system logs. Now, for a regular person, that's just a screen full of garbled text. But for an engineer, man, that log file is a goldmine for figuring out why your battery's draining or why an app just keeps crashing.
So, think of USSD codes as a key to a secret diagnostic room. They're awesome for a quick checkup. But what if the problem is bigger? What if you need to, rebuild the entire house from the foundation up? Well, for that, you need a master key. And for Samsung devices, that gateway to the phone's very foundation is called download mode.
This is where the real magic, and, let's be honest, the real danger, truly begins. This is a special pre-boot environment. It completely bypasses the main Android operating system. You can think of it as a digital operating theater for your phone.
So how is this any different from other Android phones? Well, most Android devices use a standardized system called Fast Boot. It's open, it's well-documented, pretty much universal. But Samsung? Well, Samsung does things their own way. They use their own proprietary system, download mode, sometimes called Odin mode. It's classic Samsung, right? Keeping things inside their own controlled ecosystem. Instead of using standard commands, it communicates using its own unique protocol, which Samsung fittingly named Thor.
And if download mode is the gateway, then the key to unlocking it is a piece of software with an equally legendary name, Odin. This is the PC tool that can speak the Thor protocol and allows a computer to send firmware directly into the heart of the phone.
Now here's the catch. Samsung has never officially released Odin to the public. The versions that you find online, they're all believed to be leaks from inside Samsung or their service partners. This gives it this weird, almost mythical status in the tech world. It's an official tool, but it's used unofficially by millions to repair and modify their own devices.
And you got to admit, Samsung's engineers clearly had some fun with this. The naming convention is straight out of Norse mythology. The master tool, Odin, the All-Father, commands his powerful son, Thor, who is the protocol, to deploy the firmware down to the device. It's a pretty epic way to think about flashing a phone, isn't it?
So what is Odin actually sending to the phone? It's not just one single file. A Samsung firmware package is actually a bundle of 4 critical components, and each one targets a different part of the device's brain.
Think of it like performing a 4-part transplant. In the BL slot, you load the bootloader. That's the phone's basic consciousness, the first thing that wakes up and checks everything out. The AP slot, well, that holds the brain itself, the entire Android operating system. The CP file is the modem firmware. It's the phone's voice and ears, managing its connection to the cell network. And finally, the CSC file is kind of like the phone's passport and personality, defining its region and all the carrier-specific rules.
Okay, pay attention because this next part is arguably the most critical thing to know. When you download a firmware package, you'll often see 2 very similar CSC files. One starts with CSC and the other with home CSC. If you flash that regular CSC file, it will completely wipe your phone. All your photos, all your apps, everything, gone. It's a clean factory install. But the home CSC file is designed for updates and it preserves all your personal data. Mixing these two up is, without a doubt, the #1 cause of accidental data loss.
Now, with all this power, you would expect some serious security, right? I mean, you can't just have people loading whatever they want onto these devices. And Samsung's solution, well, it's not just software. It's physically baked right into the hardware. Meet the Knox eFuse. This isn't a line of code you can just rewrite or hack. It's a microscopic physical fuse right on the phone's mainboard. It's a one-time use switch. Once you flip it, you can never, ever flip it back. It's a hardware-level tripwire designed to create a permanent record of the device's integrity.
So how does it get tripped?
It's a totally irreversible chain reaction. First, someone tries to flash some unofficial software, like a custom kernel. The bootloader, which is that first line of defense, checks the file's digital signature. It sees that it's not signed by Samsung, and it fails the check. Instantly, it sends a tiny pulse of electricity to that E-fuse, physically burning it out and changing its value permanently from a 0 to a 1.
And this is the permanent consequence. Once that fuse is blown, the phone knows its security has been compromised. From that moment on, high-security applications that rely on the hardware's integrity, like Samsung Pay or the secure folder, they will just refuse to run. And it doesn't matter if you use Odin to flash back to 100% official firmware. The fuse is physically blown, and those features are gone for good.
So all of this, Odin, download mode, the E-fuse, it paints a picture of a system that's both incredibly powerful and incredibly risky. It's a true double-edged sword for anyone who uses it.
On one hand, this level of access is an absolute lifesaver. It lets you rescue a phone that's stuck in a boot loop, you can remove all that carrier bloatware, or even do deep forensic analysis. But on the other hand, a single wrong file, or even just a loose USB cable at the wrong second, can turn your expensive smartphone into a paperweight. You can wipe all your data in an instant, or, as we've just seen, permanently disable key features of your device.
So this really brings us to the big question, doesn't it? In a world where companies are increasingly locking down their hardware, is this kind of deep internal access a feature that empowers us to truly own our devices, or is it a dangerous flaw, maybe a remnant from an older engineering culture that puts way too much risk in the hands of consumers? It's a fascinating debate about control, about security, and about the right to repair.